So I figured I'd take some time out of my day to answer some electrical questions that have come up in the forum. These are frequently asked questions, comes up all the time. I thought first I would go over the basic electrical system of the 626, starting out with the battery. In Florida, don't need a cold cranking amp battery. That's probably higher than 400. I have 550. Cranking amps is 775, I think. For everyone up north, you're probably going to want a cold cranking amp battery that's rated to your area, depending on how cold the weather drops in your area. Here in Florida, don't need it. I guess the first thing I should cover is the ignition system. I'll show you how spark gets from the battery to your spark plugs and how that spark is created. That's your ignition system. And yes, the alternator is involved in that, but the alternator's only job is to recharge the battery. It's just like it's a generator. Somewhat. The old style generators are a little bit different from modern alternators. You know, the generators that you have in the backyard that you have to put gas in and pull the cord and then they run. And that's all they do, is they generate electricity based on an engine. But in this case, an alternator basically just recharges the battery, and it is belt driven. So instead of having the gasoline engine in your backyard that drives that generator, this one is belt driven. So that provides the power to turn that generator over, and that generator has a coil, and the generator recharges your battery. That's the only thing that an alternator does, is to recharge your battery while the car is running. Without an alternator, your battery will slowly drain down because there is nothing to recharge that charge. There's nothing to keep it at 12 volts. So alternators play a very important role, and that's part of the charging system. So I guess I went straight to charging instead. Whatever. You have two ground connections from the factory. Here's one ground here, and it just goes right here and attaches to this bracket right here, and that is your chassis ground. And the second one is your negative that gets plugged into the fuse box right there. It loops around and gets plugged in right there. All of your interior power functions and engine functions and everything like that, everything in your car that's electrical will eventually, in one way or another, get plugged into this fuse box. And it's grounded out here, and then that ground goes to the battery negative, and then that goes to the chassis. And that's how your ground system. And that's just one of many grounding points. There are other many grounding points all over the frickin' car that also get grounded, but that's the main ground. And then your positive, of course, you have two leads from the positive. This one will go directly over to the starter, and that's your starter, and that's so that your starter will get the main cranking amps that it can directly from the battery positive and go straight over the starter. And this other one feeds directly into the fuse box, and that's what powers your car and everything inside and everything in the engine bay and all that stuff. So the starting system starts life there. Positive goes to the starter. Housing is ground negatively by attaching to the transmission. When it attaches to the transmission, that is its ground. It does not have a ground cable, so don't go searching for a ground cable. You will not find one. And the chassis, the engine, the transmission, and everything is grounded using ground points all over the engine bay. Actually, there's one right here. That one's probably the easiest one to see. And this gets ground from the engine itself, and then the wire runs over here and gets ground out to the chassis. All grounds will find their way to the chassis somehow, some way. So this ground actually starts from the engine. It doesn't go from the body, it goes from the engine to the body. All grounds will go to the body. The body is your actual ground, because that is what is connected to the earth. And in some countries they actually call them earths. Okay, so I think we've covered the basics of charging system, starting system. Now onto the ignition system. Your ignition system begins life at the positive battery terminal. Your ignition system begins here at the positive battery terminal, like all good electrons do. And then it flows through your fuse box, your main fuse box, and this is what distributes all of your power to your injectors, your ignition coil, your distributor, all of your sensors, throttle position sensor, MAV sensor, EGR sensors, vacuum sensors, you name it. Everything gets distributed from here, including your ignition coil. This is the external ignition coil on the automatic. Only the 4-cylinder automatic came with an external ignition coil. All other models, including i4 manual, came with the coil built into the distributor, and in the case of 98 to 2002s, in the coil pack. Now we're going to talk a minute about spark. Spark comes from your ignition coil. It gets the signal to send that spark through the camshaft position sensor or crankshaft position sensor. Actually, both need to be working. And in the case of the 98 to 2002, the camshaft position sensor is located right here. This is part of your valve cover, this blue part. That's your valve cover. And then down here is your upper timing cover, and then down at the bottom is your lower timing cover. So in my case, my spark starts out on the ignition coil. It gets a signal to send the spark, and depending on where that clock is in there, this is rotating all the time. As the engine camshaft rotates, there's a gear down here. It's splined gear, so it's on an angle. It's a cut gear, an angled gear, so that this distributor going in here also turns, going off of the camshaft rotation. And depending on where it is in that turning will depend on the firing order. So you got zap, 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 zap. Actually, there's four cylinders. So it'll go zap, 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 zap. And the firing order for the 4-cylinder is 1, 3, 4, 2. And you'll notice that that firing order is dictated by your distributor cap. Here's 1, 3, 4, 2. So as the rotor goes around, starting at position number 1, as it goes around, it goes 1, 3, 4, 2. 1, 3, 4, 2. 1, 3, 4, 2. So that's how it goes on the 4-cylinder. And I would like to thank Teppo Okinen for pointing that out. I actually had to edit my last video and re-upload this video because I got the firing order wrong. So thanks, Teppo. Good catch. And the same thing on the V6. It's pretty easy. It's 1, 2, 3, 4, 5, 6. So the signal comes in here, and then depending on where the camshaft is positioned, will feed the spark out to each plug. Where it goes where it needs to go, and exactly to the millisecond when it needs to go. That's very important. So because if you have a no start condition and you have an issue with your distributor or your coil pack, it might just be a matter of the signal not getting routed. It might get all kind of retarded. It might go, oh, let's go over here when I should actually be going over there, but that valve is open, so I'm going to get no compression, and it's just going to go blah 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 blah. Oh God, oh God. So your engine will run rough, and it will vibrate, and it might sound like and that might be because of a misfire, which is a frequently asked question on the 66 forums. There's no end in sight of misfires on any vehicle, not just the 66, any vehicle, every vehicle ever made has misfire issues, because there's so many things that can cause a misfire. It's just one of the things as a car owner you have to deal with eventually. Eventually in your life as a car owner you will have to deal with a misfire. So know the symptoms of a misfire. Here's kind of how you can break down a misfire. First thing you should do, pull out your ignition leads, pull out your spark plugs, inspect the spark plug, see if it's wet. If it's wet with oil on the tip of the electrode, that means you have oil inside your cylinders. If it's wet on only the top of the spark plug, the one that gets plugged onto the boot there, then that means that you have a leaking valve cover gasket. It is much cheaper to replace a valve cover gasket than if you have oil on your electrodes. If you have oil on your electrodes, you're looking at money for repair, because that means no bueno. That means that's a bad sign. That can be the cause or the culprit of your misfire right there. If there's no oil on your plugs and your plugs look good, then you might think, well, it's either going to be fuel or it's going to be spark related. So do a really close inspection of your spark leads, especially around here, like where they connect up, and you might have some rubbing in there, and you want to pull them up out of their housings if you still have these suckers, because they like to break like this. I don't have a single one of that attached. Pull it up and inspect the backside, because that's where it's going to rub through, is on the backside. And if you have an open in your wire and it's shorting to your valve cover and you can actually hear the spark, it'll sound just like that, just like you're clicking your thumbs. Well, maybe not exactly like that. It'll sound a lot like that. Not to be confused with an HLA tick or some other mechanical issue. It'll sound like an electrical spark. An electrical spark, if you can see it or hear it, means you have spark loss. That can be the cause of a misfire as well. And there's so many different causes of misfires, there's no way I'm going to be able to cover them all. And I'm not trying to make a misfire video. This is just an basic electrical video for the 626. Another thing to check out is your boots, and inside your distributor, your distributor cap and your rotor. There is a little small rotor in there that likes to go around. and that's what actually distributes the spark. It has a metal leading edge, and that leading edge is what allows the spark to go and where it needs to go as it's turning. That rotor can become broken. It's known to happen. Also, your distributor cap can have signs of carbon tracking, where it's trying to get out and there's a spark loss inside your cap. Usually don't see issues with distributors mechanically, it's usually electrically. And if that's the case and you can't figure out your issue, your electrical ignition issue, and you're sure it's an electrical ignition issue, you have to take it to a mechanic because they have to put an oscilloscope on it. You cannot use a multimeter to diagnose something that needs an oscilloscope. Just like your computer, there's a certain refresh rate. It does not have fast enough refresh rate to pick up those ignition signals because the ignition signals can happen in milliseconds. Multimeters, usually the refresh rate is about 1 second. And 1 second, when you have 5 different firing events inside 1 second, you're not going to be able to pick that up. So don't even try to diagnose a distributor with a multimeter. It's not going to work. You're just not going to be able to see the signal correctly. So in that case, take it to a mechanic, bite the bullet, take it to a mechanic. You're not going to be able to do a DIY repair on that. There are probably tricks, and if you know tricks to get around that, instead of using an oscilloscope, I am all ears. Pretty much covered the ignition system. Oh, and a coil pack. On the 98 to 2002 coil pack is split into 2 parts. So basically you have two banks. You have your first 2 cylinders on one bank of a coil pack, and then you have your second 2 on the second bank. So if all of a sudden 2 cylinders are completely knocked out, it's because one of the banks in your coil packs is completely shot and you have to replace it. So if 2 go out at the same time on an i4, replace the coil pack. 3 go out at the same time on a V6, it's the same thing. It's split into front 3 and back 3. Same thing, check the coil pack. I don't think that the V6 has 3. I think it's 2. I think it's just split into 2 banks. I could be wrong. I don't have a V6, and most of my stuff is just theory based on enthusiast discussions. That's all I can say. I don't have any practical knowledge or experience working on the things other than Andy's. But electrically, I have no experience on V6. I have a good theory that will let you understand how the spark is created. It's all just 12 volts, right? I mean, the entire car is based off a 12-volt battery. So how do you get 12 volts to create a spark? Because if I were to take, like 2 of these little wires inside and split them apart, I'm not going to get a huge blue spark to jump between them. It's 12 volts. The same exact as the ignition system. It's all 12 volts. The difference is amperage. Amperage makes all the difference in the world. So why doesn't this kind of wire have the same amperage as an ignition wire? The difference is this sucker right here, the ignition coil. And on the case of the automatic ignition module that feeds the ignition coil, but it's basically a mini transformer. It's a voltage booster. Most people are familiar with audio systems, right? Everybody loves audio systems. Let's say your stock base system is 100 watts, right? Everybody kind of knows that. It's 100 watts split between 4 speakers and some tweeters. So you might have 4 20 watt speakers and 2 10 watt tweeters or something like that. My point being, those guys that have the 1,000 watt amplifiers in there, and how much juice those 1,000 watt amplifiers draw and produce to make such a loud sound come out of their trunks? It's the same principle. Those amplifiers are amplifying the sound. They're boosting it. They're little transformers. They juice that signal. So imagine if in your trunk you have 9 1,000 watt amplifiers. Okay? Imagine how loud that would be. That is basically the same exact system built into that little sucker right there. Now imagine all 9,000 watts going through one of these wires at a time. That's what creates your really large blue spark. That's all of it. That's all it is. It's just there to create a spark with huge amperage, well, moderate amperage, enough to create a spark and ignite the gasoline that's being sprayed into the cylinder so that the crankshaft can go around and there you go. That's all there is to it. So I hope that analogy, that metaphor, that example has clarified just how much the ignition coil boosts it. And likewise, on the V6 and manual, i4 or V6 manual, manual transmission, that ignition coil is built into the distributor. That's why a lot of the distributors on the V6 like to go out. It's a very, very common issue, because on the V6, you know how hot it gets in there. You know, ND28, you know, showed me on his V6 MX6, it gets freaking hot. You can cook breakfast on your intake manifold if you want. It is so hot, if you even touch it with the tip of your finger, you're going to burn the tip of your finger. It gets so freaking hot, I don't know how this entire thing doesn't catch fire. Honestly, it amazes me how this thing doesn't catch fire on the V6. So not only do you have this super, super hot engine bay, but you have 9,000 volts, basically, thereabout, going through your distributor every couple of milliseconds. It's just zapping everything. Now, if something happens inside that to the crankshaft position sensor, there's also coil windings in there, so those get hot and those heat up and those expand. I mean, the distributors, just the area that it's in. This is the hottest area on the V6. Actually, it's not even that much room. There's like this much room on the V6. And the distributor is sitting right there. Actually, it's off to the side, but it's still right in the area, in the same area. I don't know if this is sounding like a complaint or not, but yeah, bad design. That's why the distributors go out, because they get heat soaked. They get heat soaked so easy. They're running so much juice through them, and they're in the hottest place in the car. It's just a matter of time before your V6 or your manual distributor goes kaput. That's it. Now, the coil packs do still have coil windings in there. It's just all electronically controlled. Yeah, I forgot to tell you that. On the coil packs, you don't have a distributor or a rotor in there. It's all electronically controlled. The camshaft position sensor, and the camshaft position sensor abbreviation is CMP, and the crankshaft position sensor is CKP. Otherwise, you got crank and cam, both start with C, so in order to not label both of them as the same exact thing, that's why CKP and CMP. That's all it is. It's just to avoid confusion. Otherwise, they would both be CMP. So when you see guys talking CKP and CMP, that's the difference. So on the 5th gens, the same thing for the V6, any coil pack really, any vehicle. When the cam gear comes around and the sensor sees that it's in the correct position, and this is all happening really, really fast. We're talking thousands of RPMs per minute. This thing is really, really sensitive. When it comes around and it sees and it says, okay, I see it's in position, it tells the ECU, and the ECU says, okay, fire. And so it goes to the coil pack, and the coil pack sent the fire signal, and it basically goes boom, little mini EMP, collapses the magnetic field, which sends the shock out, and then the coil or transformer igniter in there boosts up that signal as it's going out, and that's how you get spark. And it does this over and over. It's a huge duty cycle. Those things are really robust systems, and they have to be, because they get abused daily. It's actually a marvel of modern engineering how those things are able to last without frying themselves. But that's where, you know, rectifiers and diodes and all that kind of shit come into play. What's next? Where shall we go? Oh yes, the issue I originally wanted to make this video about. Okay, so someone's room fuse blew. Or let's say that when you open the door, your courtesy door lights do not come on either side, which all 93 to 97 owners are familiar with. If you open your doors and you don't see that your bulbs are coming on, you're like, what the hell? And then you go to turn your car on, and nothing works right, and you're like, okay, well, my dome light doesn't work either. It's because you've blown your room fuse more than likely, but let's say that your fuse did not blow. Now, in order to check your battery, you're going to want to use DC, which is the solid line with the dots below it, and most multimeters will have that symbol. If it doesn't say DC and AC beside it, that's what that means. Okay, so right here it says DC up there, so we're measuring DC voltage. Alright, so we have 12.45 volts, and that is known as battery plus voltage. And battery plus voltage is important because in all of your manual procedures that you're going to see, you will actually see battery plus, and then it will say battery positive voltage. That is the voltage that you get right here at your battery, and it's not going to be a set number. It's going to be around 12 volts. Whatever your battery charge is what battery plus voltage is. So it could be 12.45, it could be 11.4, it could be 10.6, it could be 9.0. And if it's below 9, if it's 9.0, you're going to have to charge your battery. Ideally, battery voltage is 12.4, so I am dead on 12.45. Good for me. Okay, now we're coming down into the joint box, and we're going to measure some fuses here. For a ground, usually I'll go over to the chassis somewhere, or like this thing, but that's rusted. Usually I like to use this thing, but this thing has started to rust so much that I can't really use it anymore because it's a bad ground now. It's not a good ground. You would have to etch this or sand it until it's bare metal so that it shines like silver in order for you to get a good ground contact here. So, this metal bolt here. See that bolt? Now I don't want to use the chassis because that's paint. There's no paint on that bolt, so I use that bolt as a good ground. So I'm grounded out. And now we have 12.45, and that's battery voltage. And this is the top of the fuse, right? And that's where your voltage is incoming into the car, and then the bottom is where it's going out. So the voltage here on the top of the fuse should match the voltage on the bottom of the fuse. Now, I do have a blown fuse, so I can show you what a blown fuse would look like. Okay, so if you measured only on the top of this pin, it's going to be 12.45. And you're going to say, oh, well, that's a good fuse, and all of these are good fuses because I'm all doing them on the top. If you go to the bottom, it's blown. I know that's a blown fuse without even looking at it because everything in my car is dark. My interior lights don't work and everything because this is the room fuse. This is the main fuse for almost all of the lighting inside your car. So if your interior lights go out, that's why. I have it short to ground somewhere. I know why this is happening, and I'll be able to fix that. But I just want to show you the difference when checking. This top side comes from the main fuse box under the hood. And then this goes out and distributes inside the cabin. Alright, so if you have power here and here, and your fuse is good, and you still have no lights on the inside, that means that you have a wiring issue inside the car somewhere. And then you're going to have to go pull up some body panels, trace your wires, figure out what's going on there. And that is your basic electrical diagnostic step for the 626 numero uno. Check your fuse box. See if power's getting out. See if your fuse is blown. And just by doing a quick visual inspection, if the lighting isn't right, let's say you're checking this at night, you look and you're like, well, I can't really see, it looks pretty good to me, so I don't think it's my fuse is blown. I mean, that kind of looks okay, right? No, it's blown. If you don't get anything out, it's blown. It doesn't matter if it looks good or not. It's blown. If you have something that is not working inside the car correctly, this should be step one. And that's a frequently asked question of, well, where do I start? So this is where you start. These are the things that you should be checking first. Got a video. There it is. Enjoy the video. Hope you learned something. Now you have a place to start from. Hope you enjoyed it.